Alrighty, in this video we're going to be looking at collecting and working with like terms. So that phrase that I just used, collecting, is the grouping of like terms to simplify an expression. So over here I have two examples which I am going to get to, but first of all we have to discuss what like terms even means, otherwise we won't be able to work with them. So a term, first of all, is either a number or a pronumeral that is separated from other terms by arithmetic, so pluses, minus, divide, multiplies. So I'm going to write an expression over here. We might have something like 3a plus 2b plus c minus 7. Okay, that's an expression. It doesn't equal anything. There's no equal sign there, so it's just an expression. And we actually have 4 different terms here. So that's a term, and it's separated by separated from 2b by a plus. That's a separate term. That's a term, and the minus 7's a term as well. And so each of these individual things is a term, and multiple terms make up an expression. So today, when we're working with like terms and specifically collecting them, we're going to be trying grouping. We're going to try to group the ones that are similar together. Now, 3a is the only term in this expression that has an a in it. This 2b is the only one with a b in it. This c is the only one with a c in it. And the 7 at the end is the only one with no variable at all attached to it. So it's a constant term. So none of these are like one another. However, if we look at a different expression, I'll call that expression 1. Expression 2 could be something like 3x plus 2x plus 4x, let's say. Now in this instance, excuse the lighting, in this instance the x's are in every single one of these terms. And that means that this 3x is alike this 2x, which is like this 4x. And so we need to have a skill to recognize that. So I highly recommend you grab a different color, maybe a red pen if you're working in black or blue, and you go through, or a highlighter, and you go through and you identify all the like terms. So in this expression at the top, there are no like terms. Here, the 3x is alike the 2x, which is like the 4x, and so all 3 of those are like terms, and we can group them together. So the next line in this expression, I could say that expression equals, there's 3 x's here, plus 2 more would give me 5 x's, plus 4 more would give me 9 total x's. So I could write that expression is equal to 9 lots of x. So those things are equivalent, those two lines. That's the skill we need to find. It's nice and simple there, where all of my terms are like terms. But it gets a bit trickier when I move over here, and I've got some like terms, some unlike terms, and I need to work through them to find the ones that I'm going to collect together. Okay, so up in this first example, this is the cognitive verb that you're likely to experience, the word simplify. It wants you to take this expression and reduce it down as much as possible, typically by collecting like terms. So I'm going to use 2 different colors here. I'm going to use pink and yellow in order to underline the ones that are like one another. I probably need more colors, but I'm just going to have to do it one at a time. So first things first, we have a 2. So we start with a 2 and underline it in yellow. And I'm going to have to go through the rest of these and see if I can find any terms that are just numbers. Okay, so this has an a in it, so it's not like it. The b makes it not like it. Another a, another b. The 1 at the end is like it. But I need to ensure that I bring this negative sign with the 1. So I'm going to underline all of that. So now I have 2 like terms here. I have a 2 and a minus 1. And they're the only 2 numbers. And I can actually work with them now. And I'm going to say 2 minus 1 is 1. Okay? Now it's very important to notice that the minus 1 belongs to the 1. Okay? It's got nothing to do with this b. I'm not subtracting anything from b. The minus 1 comes from the 2. So 2 minus 1 is 1. I'm then going to move over to my next variable in the sequence, which is my 4a. So my 4a is going to be grouped with any other a terms in my expression. So that's a b. It doesn't belong with it. This 3a, yes, that has an a in it. So I'm going to underline that whole one there. And lastly, I've got a b, so that doesn't work with it. And so now I go back and I look at these and I say, okay, 4a minus 3a. Remember that minus belongs with the term after it. So 4a minus 3a is going to leave me with 1a, which we can just write as a. And lastly, I don't have a different color for this, I only brought two. So I'm going to circle this one to make it distinct. My b term here, my plus 2b, is going to group with this b here. And that's the rest of my terms. So now I have to work with them. 2b plus one more b gives me 3b. And that is as simplified as it gets. If you're unsure if it's as simplified as it gets, go back through your final expression here and check if there are any more like terms. So 1, there are no other constants. A, there are no other a's. B, there are no other b's. So we're done. That's as simplified as that expression gets. Okay, moving on to example 2 now. Again, we're going to be simplifying. And again, you might see the question as simplified by collecting like terms, but they are the same thing, okay? When we're simplifying, we are collecting like terms together. So I'm going to go through this from left to right again and ensure that I'm collecting all of the ones that are the same. So my yellow pen, I start with a constant 5. I need to check if there are any more constants in my expression. So 5, that's an x squared, that's an x, that's a y, that's an x, that's a y. There are no more constants, so I can actually go ahead and say the simplified version of all the constants is just 5. And now I have to move on to my next one. In fact, because that's the only one, I'm going to save my yellow underlining for my next variable here. I'm going to start with x squared. Now this is the tricky one and it gets a lot of students. So if you're paying very careful attention now, you won't make this mistake in the future. This has an x in it, but it is x squared. X squared is different and not a like term with just regular old x. They are similar but different. You can think of them as cousins, not brothers, okay? So x squared and 2x do not collect together. So when we're looking for x squared, we look for all the x squareds, not just x's. So not x squared, not x squared, not x squared, and not x squared. So again, that is the only version of that term. So I'm just going to write down 1x squared again. And for the second time in a row, I don't actually need my yellow underline to group two pairs of terms together. Okay, my next one here, this time I've got plus 2x. I'm going to go ahead and look for any more x's with the power of, well, 1. So x, that's a y, that doesn't count. Aha, 3x. That belongs with it, and I'm bringing the plus with the underline. And the last one's a y, so I don't group that one at all. So now I get plus 2x, plus 3 more, gives me plus 5x in total. And last but not least, in my pink underline, I'm going to move to my next term, which is minus y. And I've only got one more term, and it has a y in it. So I'm going to group them together. I've got minus 1y. And I'm adding 4. So it's kind of like doing minus 1 plus 4, which is 3, but I have 3 lots of y. Alrighty, so collecting like terms, there are 2 tricks that you need to look out for. The first one that I mentioned was that when, let me go back to this example, the symbol, so the minus or the plus, belongs to the term after it. Okay, not the one before it, the one after. So this y is a negative y. This 2x is not minus 2x, it is plus 2x, okay? So that's the first trick that foils a lot of students. The second trick is that x squared is not, repeat after me at your computer with me, not like 2x, okay? X squared is, correct? X squared is not like 2x, they're not alike, you can't do anything with them. So our final simplified expression is 5 plus x squared plus 5x plus 3y. Okay, hope this helped with you working with like terms.